Hello everyone. Good day. I hope everyone is well, everyone is safe. So this is the third part of the video where we are learning how to create data loaders for different scenarios of data augmentations in PyTorch. And in the third part, which means this video, we are going to see how we can create a class-specific data augmentation to increase dataset size of selective class. So say you have two classes and it's an imbalanced class and you just want to increase the dataset size of the class which has lower number of samples. In this case, the cats. So we'll see how to do that. So in the first part, we have seen how to do the straightforward one-to-one augmentation with one input and one augmented output. And in the second part, we saw how to do augmentation to increase the dataset size. That is for each input image. Each one of the input image will have multiple augmented image, and in that way we can increase the dataset size. And in the third part, it's similar to the second part, but here it's combination of the first and second scenarios. Here we will increase the dataset size, but only of selective classes. So in the previous case, for every input image we created, three or four augmented image. Here we will create multiple augmented image, but only if it's a cat class and not a dog class. So the scenario of class imbalance. Said that, if you haven't watched the second video, I would recommend to go and watch it because this will be very much similar to the second one that we discuss, here. And also, we will be defining again a custom collate function like the way we did in the previous video. So let's get started. And in this video as well, we are going to cover both the scenarios of data generator. That is one when we preload the images while initializing the generator function. Another where we don't preload the images, we just load the image names. So let's see the first scenario first. And again, for this example, I have this separate annotation file called train labels imbalance, where I have 50 cat samples and 100 dog samples. So there's an imbalance in the class, and we'll use data augmentation to increase the size of the cat class so that both becomes 100, and we have a balanced data set. Okay. So let's go to the code. So if you remember from the previous video, there won't be much change, just that in order to increase the data set size, what we used to do is we used to define list of transformation, and then we used to pass this transformation list into our data loader function. And for each of the transformation, we have this augmented image, and that augmented image we were appending so that we have as many augmented image as number of transformations. Okay, and this we were doing for every image. Now just one change will come here in the new data generator, that here we will not do for every image, we'll put a condition of class label. Okay, so for us the cat class label is 0 and we want to increase that. So what we'll do, we'll have our list of transformation, and we'll say only if the uh, the label is 0, then we pass this input image to all this transformation and then append for each of the transformation one augmented image, so that we increase the a data set size for this specific class. And if it's not label 0, if it's not cat, if it's just dog, then just apply one transformation and append it, so that it will be like a scenario 1, like the first scenario of one input and one augmented output. Okay, so just by putting this label, we can create this condition. Just this change is required from the previous data generator. Okay, so that's it. And I think then we can run the code. It's pretty much the same. Just this part which I said. And since this is the first type of data generator, so while initializing itself, when we are loading the data, while initialization itself, we are going to read and transform and append it. Okay, so let's run this. And here I have changed the labels to this. And here if you see, I am just defining one transformation. So this is obviously the default resize, and just one transformation of random perspective, because I want to double the cat class, because there are 50 samples. I just want to make it 100. If I want to make it 150, 200, then I could have even added more of the transformation. So for now I just want to create a balance. Then pretty much everything is same. We will then call this data generator function with our annotation file name and define transformation. And let's see the number of data sets. So it should be, around 200, because it got, so you can see it's 200. Although here it's just 150. So if you see the total data set, it's just 150, of which 100 dog and 50 cat. And here, because of augmentation, we have increased our cat dataset size. Okay. Now, if I take one of the sample, let's take sample 20. So you can see this is the normal cat. And because for every image I have augmented and appended it next to it. So if I take the index 21, I will see the same image, which is, augmented with random perspective transform. So you can see the deed has been done. And then if you have to create data loader, you will use the defined, the object of the data generator, which we just defined a few cells ago. We'll define the batch size, and it's same pretty much. And you can see the batch size is 12, 3, 128. And if you just then see the visualization for this, then you can see the dog images, are not augmented, because if you see the transformation which I have defined, T0. I mean, for cat, I'm doing both the transformation, and for dog, I'm just doing T0. So T0 is just resize. Okay. So you see for the dog, nothing has changed. And only if there's a cat image, you will see the cat image would have gone through this random perspective augmentation. So this is the for the first type, where we are reading the images and loading it while initialization itself. So now let's look for the second scenario of data generator. That is when we don't read the images, while initialization, but just read the image names. And when we are calling the, generator function and reading the samples, then we read the images. Okay, so let's see for that. So the change would be obviously that in the load data, now we will not read the images or do any transformation, but instead we'll do in the get item, uh, get item, function when we call the samples. Okay, and if you compare to the previous scenario, so the previous scenario is when, for every input we were doing augmentation. So let's first just go through that. So what was happening in the previous scenario is we were reading one of the image, and then we had this list of transformation, and for every transformation we were, creating a augmented image, and then we were stacking it in a form of tensor for both the datas and the label. Okay, so for one input, like when you just ask for one sample, it would give you, because we were using 4 augmentation, it would have given you 4 by 3 by 128 by 128, and 4 output labels as well, which is obviously the same thing. So for example, when we just call for one sample of cat, on when we just call for one sample of cat, we will be getting 4 images here, because it is getting transformed for every call. And that's why, the data was 4 by 3 by 128 by 128, and tensor was, 4 labels. And in this new scenario, where we have to do this kind of augmentation, but only for cat. Okay, so what we have to do is basically we have to put some condition that do this appending or creating this, increasing the data set size only if it's label 0. So let's see how we can do it. So basically one if clause, and if it's a label 0, then we do the thing that we did for the previous data generator, that will pass it through the list of augmentation, and will augment it, and then we'll create a stack, of as of now. So here we are using like 2 transformation. So here the shape would be 2 by 3 by 128 by 128, and there'll be 2 labels. But if it's not a cat, it's a dog, then you just simply apply one transformation, and here you create image and labels of shape, 1 by 3 by 128 by 128. Okay, because here we are not increasing the data set size of dog. So that's all, that's the change you need to do. So let's run this code, and then we'll see. Okay, so now this is my, so you can see T0 and T1 are the only 2 transformation, where T0 is just resizing and T1 is random perspective. So let me call it. So again, like in the previous scenario as well, you will see the number of data set will be here just 150, because here we are not augmenting anything when we initialize the data loader. During init, we just read the file names, and in the file names there are just 150 samples. Only it's on the go when we are calling the samples, then we are reading and augmented it. So that's why it's just 150 for now. Now let's call one of the sample, and let's see when we call how it shows. So when I call this sample 20, which is a cat, you will see for cat it will return two images because I have two transformations. And again, the size of sample would be 2 by 3 by 128, and there will be two labels. One will be original resize cat, and another will be augmented cat. But had it been, say, dog, let's say, for example, 100 index is a dog. So you'll see for the dog, it won't create any augmentation and we'll just have one sample. Okay. So you can see the data generator is working as intended. Now let's create data loader out of the data generator. So for the sake of explanation, let's first use the default collate function, which just stacks, the samples which is fetched from data generator. And I'm using a batch size of 12. And when I try to fetch one batch of data, it gives me error saying that the tenses could not be stacked. So in the previous case, when we were calling it, it was creating a stack, but it was creating another dimension. So if you see, for every input there were, four augmented output. So there was like four for every one sample. There was this 4 by 3 by 128 by 128, and we when we call a default collate of a batch size 12, then it becomes 12 by 4 by 3 by 128 by 128. So we created a custom collate function where instead of getting this, we get a 48, you know uh, directly create a tensor of 48 images, one for each, four for one of each input image, and we were getting 4 by 3 by 48 by 3 by 128 by 128. Okay, but here, because one the dog is of shape 1 and this is of shape 2, we cannot stack it. Okay, so we have to open this stack, like we have to create in a different way, and that's where we'll define another custom collate function. So what we'll do, so whatever the item that we were getting, we will be getting, so we will get the data and label pair. So first of all, whatever data we'll have, we'll open it here in this data list, and for this label we'll again open it in this label list. Okay, so say we have a batch size of 12, and for one sample, if it's a cat sample, it will be of shape this. If it's a if it's a dog sample, it will be of sample this. If it's a cat sample, it will be of size this. So we will concatenate on this dimension 0. So it will concatenate over this, so it will be, for in this example, it will become then 2 plus 1, 3 by 3 by 128 by 128. But we'll be calling a batch of 12, and within that batch of 12, because we'll be shuffling it, there will be both cats and dogs. So let's see, we'll not know the number beforehand, but let's see what it gives us for now. So it gives us 15. Okay, so it's let's see then how many cats and dogs. We can actually see it right now, and we'll see. So we get 15 samples of 3 128 by 128, and among this 15, then there were 1 2 3 4 5 6 7 8 9 dogs. Okay, and there were 3 cats because I called for a batch of 12. So 9 dogs and 3 cats, but for all the 3 cats it doubled, so 9 plus 6 it became 15. So you can see we call for a batch size 12, but since we in the previous case every input became 4 times, so it becomes 48, and here just the cats, so it becomes 15. So you can see we have created a data loader which gives us the data and augment only the cat class or any selective class. Okay, and yep, we can then, yeah, we can in this way that we can create this data loader for the second scenario of data generator, where we are reading the data on the go. Just that we have to define a custom collate function to handle this scenario of stacking when we create the batch. Okay, and that's it. I think just I mean, if it's a little bit confusing, just go through the code, just run it, and just try to see the images, try to align the tensors, and I think it will totally make sense. And you can do it for I just show it for binary classifier. You can also do it for multi-class classifier, and this will be especially helpful when we have this class imbalance and you just want to increase the dataset size of just one class. Okay. So that's it for now. I hope you got some idea, you learned something, and I hope this was useful. And this is the last video for this data generator thing that we were doing, where we covered the first scenario, just one input and one augmented image. The second scenario, for every input image, we create multiple augmented image to increase the dataset size. And the third scenario, that is, we increase the dataset size and apply multiple augmentation just for one specific class. So that's it for now. The codes, the Jupyter Notebook and all the code would be in my GitHub and the link would be provided. Thank you very much for sticking with me. Till then, keep learning, keep exploring neurons. Take care, be safe. Bye bye.